functions tonight, like I said, and then we'll look at those supplement things too. So so exponential functions have different applications, like in finance, obviously with loans and stuff. Any type of growth of populations, different biological situations like that. And there's one kind of an interesting application in your project that I'm going to give you about exponential functions. Also, any kind of type of like a disease or anything that's growing is going to be exponential. Right? Also could be decaying. A classic example of that is right buying a new car and how much it depreciates. All right, over time. That's exponential. All right, so there's a lot of different applications of exponential. So let's just take a look at something simple here. So we'll put time here, and we'll do fish. Okay, like fish in a pond. Okay, So if we start out with a certain population of fish, let's say 2, and then they produce and we reproduce and we get more. So let's say that we're going to get 1. Let's just go double the amount. All right. So then that's going to be 4, 8, 16, 32. That is an example of an exponential type of idea, all right, where this population is doubling, all right. So there is what we call a growth factor and a growth rate to this, okay. Now, most of the time when you hear about exponential stuff, they talk about a growth rate rather than a growth factor. So this is the one that's most commonly known. The growth rate, or excuse me, the growth factor is how much these are growing by each time. And in this case, it's doubling, okay? So the growth factor would be 2 in that case because it's doubling each time, all right? To find the growth rate, here's how we would do that. We're going to take 2 populations. Let's say we take the first 2. 4, we subtract 2 to find the difference, and we're going to divide that by the previous number of fish in this case. So 4 subtract 2 would be 2. 2 divided by 2 is 1. So this has a 100% growth rate. All right? And it wouldn't matter which numbers we picked. It's going to be the same. If we pick the last 2, it's still going to be 100% growth rate. So our equation that describes this looks like this. Y equals A times B to the X. This is an exponential kind of equation where A is our initial population, or value, I should say. It could be either one. In this case, it's population. Could be anything. All right. And B is the growth / decay factor. Okay, so if we had another one, same idea here. and we started out with 2, but this time we're going to triple. All right, and we wanted to find an equation for this. We'd have y equals a times b to the x. A is going to be that initial value or initial amount. So what's our initial amount? Now this is the time, and this is whatever you want to call it, 2. Okay? Times, now we want to find that growth factor. So what is this growing by each time? Times 3, right? So 3 to the x. Okay? That's how you find an equation of it. If you need to find the growth rate, okay, let's do the growth rate real quick, and I bet you'll see a pattern here. So if we take 6, subtract 2, divided by 2, that's 4, divided by 2, which is 2. So the growth rate is 200%. All right? Now, the growth factor was 3, and the growth rate is 2. And on the first one, the growth factor was 2, and the growth rate was 1. So what's the relationship there? For 3 it was 2, and for 2 it was 1. So what's the relationship between the growth rate and the growth factor? One's what?
As one increases, so does the other?
Yep, that's true too. But what about if we looked at, so growth factor here is 3, and the growth rate was 2, okay? And up here, it was 2 and 1. So how far apart are they each time, it looks like? 1. And that's correct, okay?
Because if you have, like, say you had a population of 2, and then the next thing came out, you would be 2 again. Since it's 100% of itself already, you can't add any more.
Yeah, so that kind of, so the factor is always going to be 1 more than what the rate is in this case, okay? So when something grows by 100%, that actually means it's doubling, right? Okay? So, and if it grows by 200%, then it's actually tripling. So B is equal to 1 plus R, where R is the rate, all right? Now that same thing holds up for populations that decay. I kind of rounded this one a little bit. Okay, so this one is a decay situation. So then we would say this is kind of a decay factor. But the A doesn't change. So what's the A in this case? 100. All right. Now we want to find the growth or the decay factor. Well, each time this is going down by about, or how much? Half, right? Okay. I just didn't put 12.5 there. So then that would be what that looks like. Okay? So the decay rate would be 1, but since this is a negative kind of a decay, so it's going down, we think of it this way. So it would be 0.5 or 50%. That would be the rate. All right, so it all centers on that 1. Whether it's up, it's growing, that means we're going to add the 1. If it's decaying, then we're going to subtract from the 1 to get the rate. So for example, here, if we have 100, okay, and then, let's see, let me go 80 here, 64 there, and that's about the range of my, I don't know what 3 would be, but we'll come back and get it. Okay, y equals a times b to the x. All right, so a, again, is going to be 100. Okay, and we can just divide these two to figure out what that factor. So if we took 80 and divided it by 100, we would get 0.8. Agreed? So 0.8 to the x would be my equation. Right? But the rate would be equal to 1 minus 0.8, which is 20%. Okay. So the rate, we're just kind of, to find that rate, you're just kind of dividing two consecutive things. If we did the same thing, we'd take 64 divided by 80. We get 0.8 also. Okay. Anyway, that's kind of how it works. All right. Let's see. They have you do a lot of little things with exponents and exponential, so let's do that here. Let's do, I'm just going to jump into decimals for a second. Okay, we kind of touched on this a little bit. Just want to make sure we got it. So if we have come on. If you have some numbers like this and you don't see the pattern, even though we do see the pattern here, remember to find the exponential equation, all you have to do is divide these and it will tell you what it is. So 4 divided by 1, 16 divided by 4, and 64 divided by 16. Okay? So, like when you get your project today, it's going to have some data here, and you're going to have to try to find an exponential equation for that. All right? Well, it might not always turn out to be nice numbers here, like 4s, like this is. But if it doesn't, just average them and get a good eyeball average for it. Okay? So there will be some questions there in the book where it's going to have you decide whether they're linear or exponential. So obviously this isn't linear because it's growing inconsistently. All right? Not at a constant rate. Okay, so this would be exponential. And then the equation just would be y equals 1 times 4 to the x. Okay. Any questions on any of that stuff that we're doing? It's pretty basic stuff, I think. Okay. So let's do this. We'll take a little let's take about a 5-minute break here. I want to come back and do one more thing with exponentials before we do anything else. Okay? Okay, looks like everybody's back. So, here's the tricky parts that they have in this assignment. They're having you solve these equations here. All right? And they're exponential. So let's for example, let's look at this here. So 1/8 to the x is equal to 2. All right? So what we want to do is we want to try to get this here, all right, broken down so it looks like this to a power. All right? So these things are always going to be somehow written as a power of each other. So for example, 8 is 2 to the third. Does everybody kind of see that? Right? 2 to the third. I can rewrite 8. That's 2 to the third. Okay? So here's how this works. So then you come down, you go, okay, this is 1 over 2 to the third. I have an x here. That's equal to 2. All right? Now, what I want to do is try to rewrite this so that I don't have it as a 1 over 2 to the third. I don't want that. So remembering my properties of exponents, and if I have a 3 here on the bottom, I can rewrite this as 2 to the negative 3 to the x is equal to 2. All right, because if I have a negative exponent like this, it just drops this to the bottom. Okay, so if I have 2 to the negative third, that would be 1 over 2 to the third. So it goes to the bottom. So here, I'm trying to get it so it looks like this thing, so I want to kind of reverse that process. So I got 2 to the third, I want to move it back up here to the top, but that makes sure that negative is going to be, exponent's going to be negative. All right, then, what am I going to do with these two things? What's my exponential power say? Multiply them. Good. Now, both of these things are the same, okay? They're the same base, we call it. So, all I have to concentrate on is the powers on those numbers, because the bases here are the same. So I lost my color. So now I'm going to go negative 3 to the x, or negative 3x, excuse me, is equal to 1, because this is 2 to the 1. And then I can just figure out what the answer is. But the tricky part is recognizing, okay, how do I get from this 1/8 to the x to be a power of 2 so that I can then rewrite it and work with it. All right, that's the tricky part, is how I can arrange that. Okay, so let's try another one here. This one will be a little bit simpler here. Oops, not a negative. Okay, so it looks like that. All right, so now what I have to do is figure out, well, how do I get this to be written as a power of 3? So how do we get 81 to be written as a power of 3? What's that going to look like? Well, let's see. We got 3 to the first is 3. 3 to the second is 9. 3 to the third is 27. So it's 3 to the fourth. Here we have a negative x. Now see how both those things are the same. So that means that we have negative x is equal to 4. So then what is x equal to? Right. Right. So again, the tricky part is trying to get this here, recognizing that, oh, this is just a power of 3 there. Oh, somehow you're going to be able to do that. Right? They're not going to set you up so this is 5, this is 81, and it doesn't work at all. Right? They're going to set you up so that those things are somehow can be written as a power. Right.
So is the answer x to the negative 4?
X is equal to negative 4.
Yeah. You don't have to worry about any of the other stuff. You just want to know what x is?
Yep.
Okay.
Yep. You're just trying to solve it. Right? Just trying to solve what for x is. Okay, so let's try one like this. This is one similar to what's on, I was looking at one of the assignment problems. All right. So here we have a 3, and here we have a 9. So if we can write that 9 as a power of 3, that's really going to help us. So 9 to what power is going to give us 3? So 3 to what power? So we're going to have this, okay? I see how I took, so here we're taking 9, writing it as 3 to the second, okay? X to the square just stays there, nothing happens there, all right? What are we going to do with these two things, though, right here? That's good, we're going to multiply them, right? So we get this is equal to 3 to the x, so it looks like that. Now, look. They're both the same. That's what you want to happen. We want them to both be the same. So then all we got to do is worry about the top parts. Okay, we don't have to worry about anything else. Because once these two bases are the same, that means their powers are going to be the same. So now we have that. And we got to solve that little equation. Okay, it's a quadratic, so I'm just going to automatically set it equal to 0. Because that's how you solve a quadratic. And then the easiest thing here to do would just be to factor it. So I think I'll take an x out of this. And there's one answer. And the other one would be if we set this equal to 0. And we get 1/2. So there's my answers. Okay. Well, we probably would have never gotten that if we went from the beginning. That's why you break them down into those powers that are the same. Okay? That's what you're always trying to do. Any questions on those ones? They're kind of tricky. You really have to recognize them. Okay, I'm going to do one more, and then I'm just going to kind of let you do a couple problems before we jump to our quiz here. So, if you want to look on 307, okay, question number 85 says, determine an exponential function whose graph is given. Okay, so they have this, and they have here a point, and here another point, and here another point, and here a point. And this one is 0, 1. That's what's right there. And this one is 1, 3. And this one is 2 and 9. Okay? And here it kind of looks like this. All right. Y equals A times B to the X. All right? So, from this graph, we can figure out stuff because it's telling us points, so we know what's going on. Can anybody see what the A value is in this case?
1.
Good. Why is it 1? Yeah, it's the y-intercept, right? That's the initial value. X is 0. Y is 1. That's got to be A. Now, how are we going to find B given that we have this point, and this point?
Oh, you divide them, right? Yeah, you subtract them and divide them by the by 2. Is it by 2?
So which one? So I'm hearing a couple things. One I heard we're going to divide them, and one I heard we're going to subtract them.
You do 9 minus 3 divided by 3.
Okay, hold on. So you're saying we can take 9, which I assume you're getting from here, right? And the 3 from here. Okay, 9 minus 3. You're saying? and then divide by 3. So that's going to give us 6 over 3, which is 2, right? So is that B?
Yeah.
B is 3. Why?
Because it beat 200%, so one above that is 3.
That's right. Remember, 1 is that cutoff, right? So you're finding the rate, okay? By doing it this way, you're saying, well, I'm finding the rate, which is okay. It's just you got to remember you're going to have to add 1 to it to get the growth. So it would actually be 3. All right? Now, could we have gotten that differently? Yeah. We could have looked at this guy, right? And this one and do what with them? How could we get 3 out of there?
9 divided by 3.
9 divided by 3, right? Okay? That's not a whole lot different than having this and this and this. Okay? There's my growth right there. Right? It's not any different than having a table. It's just it gives you points. Right? So same idea. So I think we hit a lot of everything that was on there. I don't think there was anything I didn't cover. All right?